There is something deeply broken in the way we build today, and it's costing us more than just money. Back in 1872, a survey was conducted on Borgen Stave Church, a wooden structure in Norway that had been standing since 1180. Outside, the temperature had plunged to -31 degrees Fahrenheit. Snow was piled several feet high. The wind roared through the valley with enough force to shred a modern expedition tent. And yet, inside the church, with no HVAC system, no fiberglass insulation, no double-paned windows, the temperature held steady at 46 degrees. No fire, no external energy source. The structure itself, built entirely of solid wood, using techniques long abandoned, kept the occupants safe and, honestly, surprisingly warm. If that surprises you, just think about your average modern home. Turn off the heat when it's 14 degrees outside, and within hours the temperature drops below freezing. Pipes burst. Homes become, well, uninhabitable. What did builders 800 years ago understand about heat and shelter that somehow we have forgotten? Today we're going to uncover the principles medieval Scandinavians used to survive some of the harshest winters in history. Principles that can totally transform the way you think about building, heating and surviving today. But first, drop a comment below. Have you ever faced a blackout in winter? How long did your home stay warm? An hour, 6 hours, or did you see your breath after 30 minutes? Let us know, because what you learn today will change your approach to every modern building you encounter. And before we dive further, if you're passionate about history and survival, hit that like button, subscribe, and share this video so others can benefit from these forgotten techniques. Let's rewind to 2010. A research team at the Norwegian University of Science and Technology set up an experiment with two identical 430-square-foot structures. The first was a reconstructed medieval log cabin built to 14th century standards. Solid logs, hand-hewn, joined with tongue and groove. No modern insulation or vapour barriers. The second was a modern prefabricated house with R25 insulation, vapour barriers and triple-glazed windows. On paper, the modern house should have been superior. Yet when both were heated to 68 degrees and then the power was cut, the results were, well, shocking. The modern house dropped to 36 degrees in just 9 hours. The log cabin? After 48 hours, it was still 54 degrees. After 72 hours, it remained at 43 degrees, above freezing and fully livable. Why did this happen? Modern engineers point to R values. The log cabin's walls measured around R10, while the modern house boasted R25. By conventional logic, the modern home should have won. But R value measures only steady-state heat transfer. It ignores thermal mass, the hidden factor that determines whether a home survives a blackout or becomes, an icebox. A 12-inch thick log wall of old-growth pine weighs roughly 80 pounds per linear foot. Wood's high specific heat allows it to store enormous amounts of heat energy. Once heated, the wood slowly releases it over hours or even days, creating a thermal buffer. Now, modern walls, by contrast, are light, thin sandwiches of drywall, fiberglass and siding, with little mass and really no capacity to store heat. Thermal mass alone is not enough. Medieval builders also mastered airtight construction. Modern homes, despite advanced building materials, leak like a sieve. Blower door tests show the average house has gaps equivalent to a 20 by 20-inch window left wide open. Those tiny leaks allow cold air to pour in constantly, forcing your furnace to chase invisible enemies. Scandinavian log cabins, however, use scribe-fit joinery and chinking made from spongy moss and clay, reinforced with animal hair. The result, walls that were airtight, breathable and durable, tighter than many modern passive houses today. The third element is the heating strategy. Open fireplaces are inefficient and often counterproductive, but the Scandinavians used masonry heaters, massive stone structures that absorbed a quick, intense fire and radiated heat slowly for up to 18 hours. Radiant heat warms people and objects directly, meaning you feel comfortable even at lower air temperatures. Modern forced air systems must heat the entire volume of air to achieve the same comfort, wasting fuel in the process. Interior design reinforced this efficiency. Low ceilings, small rooms, and clear thermal zones ensured heat stayed where people needed it most. Bedrooms stayed cool for sleeping, while living and cooking spaces were warm. Even the foundation played a role. Modern slab-on-grade construction acts as a thermal bridge, just siphoning heat straight into the frozen earth. But medieval cabins, well, they were elevated on stone piers, with thick wooden floors insulated with moss or sawdust, which really broke the heat loss path into the ground. Every detail, from wall thickness to room layout to floor construction, was designed to hoard heat and survive extreme winters. Why did we stop building this way? Speed, cost, and cheap energy. After the Second World War, we needed homes fast. Labour-intensive log construction gave way to stick framing. Thin walls were cheaper than solid timber. And with cheap fossil fuels, well, why bother building for efficiency? Today, energy is no longer cheap, and our homes are showing the consequences. Grid failures, rising utility costs, and increasingly harsh winters are exposing the fragility of modern construction. In contrast, Europe is seeing a revival of solid wood construction and mass timber. These homes combine centuries-old wisdom with modern technology, drastically reducing energy use while remaining livable during power outages. If you're planning to build or renovate, take note. Integrate thermal mass wherever possible. Use stone or heavy timber to store heat. Seal every leak. Design compact, compartmentalized layouts. And consider radiant heating strategies. This isn't nostalgia, it's physics. Homes built with these principles are resilient, energy efficient, and capable of surviving the kind of cold that would cripple a modern stick-built house. Medieval builders weren't primitive. In fact, they were physicists, craftsmen, and survival experts who worked with nature, not against it. Every log, every joint, every hearth placement was, optimized for life in extreme conditions. Today, we can learn from them. By embracing thermal mass, airtightness, and radiant heat, we can build homes that aren't just shelters. They're honestly life-saving structures built to last centuries. If you found this valuable, Make sure to hit that like button, comment below with your thoughts on surviving extreme winter conditions, and subscribe to Warfront Survival for more insights from history that can save lives today. Share this with friends who care about survival, resilience, and the art of building homes that endure. The wisdom of the past isn't just interesting. It's a roadmap for surviving the present and the future.